Hey student, how are you? Welcome to our session on properties of logarithms. We're going to go through a couple of examples of each of these properties. Log of 1. Log base b of 1 is equal to 0. If we rewrite this logarithm using exponential form, you get the base b raised to the 0 power. The answer to a logarithm is the exponent, and anything to the 0 power is 1. Let's evaluate. Log base 4 of 1. If I rewrite this using exponential form, I get 4 to what power is equal to 1? Well, 4 raised to the 0 power. Anything to the 0 power is 1. Natural log of 1. Natural log is log base e. So e to what power is equal to 1? Well, anything raised to the 0 power is 1. Common log is log base 10. And 10 raised to what power is 1? And we get 0. Anything raised to the 0 power is 1. Next. Log of the same number as the base. Log base b of b is equal to 1. We can rewrite this using exponential form. B is the base, 1 is the exponent, and then equals b. b to the first power is b. Let's evaluate. Log base 5 of 5 is equal to 1, because 5 raised to the first power is equal to 5. Natural log of e is equal to 1, because e raised to the first power is equal to e. Natural log is log base e. Common log. Common log of 10 is equal to 1, because 10 raised to the power of 1 is equal to 10, and common log is log base 10. Next. The product rule. Log base b of m times n is equal to log base b of m plus log base b of n. So we're going to go both ways here, expand and condense, using the product rule. Log base 7 of 3 times x, we can expand this and we will get log base 7 of 3 plus log base 7 of x. All right, and the second one here, I'm going to go to log base 2 of 12, and we'll expand. Log base 2 of 4 plus, and I'll show you why I picked that, log base 2 of 3. So 4 times 3 is 12. And now we can simplify log base 2 of 4. 2 to what power gives you 4? And we can get 2. So we can simplify this to 2 plus log base 2 of 3. And then condensing, going the other way. Common log of 5 plus common log of x. The bases do need to be the same. The bases of the logarithms do need to be the same in order to condense. And we will get log of 5 times x. And log base 2 of 9 plus log base 2 of 3. We can condense using our product rule, and we get log base 2 of 9 times 3, which is 27. Next, we'll take a look at division, the quotient rule. Log base b of m divided by n is equal to log base b of m minus log base b of n, and the order does matter. Order for division, order of subtraction matters. And let's expand. Log base 7 of x divided by 4 can be written as log base 7 of x minus log base 7 of 4. And the next one, log base 2 of 3x minus log base 2 of 8. And now we can actually expand 3 times x, log base 2 of 3 times x, using the product rule that we just learned about. Log base 2 of 3 plus log base 2 of x minus, and then log base 2 of 8, 2 to what power is 8? We can simplify that to 3. So we get log base 2 of 3 plus log base 2 of x minus 3. And then going the other way, condensing, log of 9 minus log of x, we get log base 10 of 9 divided by x. And the next one, log base 2 of 12 minus log base 2 of 3, we get log base 2 of 12 divided by 3, which is 4. And then log base 2 of 4 is equal to 2. Next, my favorite property, the power rule. This is really useful for solving logarithmic and exponential equations. The power rule, log base b of m raised to the n power, you can take the exponent n out from the logarithm and put it as a coefficient multiplied out front. So we get n times log base b of m. And you can go the other way and put the coefficient back up into the power in the logarithm. So we'll do exactly that. Log of x to the 4th power, we can bring down the power of 4 as a coefficient outside and then do log of x. And then natural log of the cube root of x, we can rewrite this as the natural log of x raised to the 1/3 power. The cube root, third root, is the 1/3 power. And now we can take the 1/3 power out from under the, out from the logarithm, put it out front as a coefficient, and then natural log of x. 1/3 natural log of x. And then condensing. Log base 3, and then we can put the power back up into our logarithm, and we get log base 3 of 100. And the last one, the last one for this property, log base 5, and we'll raise 7 raised to the 1/2 power. And the 1/2 power is the square root, so you could also write this as log base 5 of the square root of 7, square root of 7. Next. Raised to a log. Base b raised to the power of log base b of x is x. Now let's take a look and simplify. 3 raised to the power of log base 3 of 5 is equal to 5. E raised to the natural log of 9 is equal to 9. And 10 raised to the log of e is just e. And our last property, the change of base property. Log base b of m can be rewritten with a different base for your log. So we can change it to log base c of m, the original argument, over log base c of b, the original base. And we'll do a last 2 problems here. Let's rewrite log base 5 of 7 using common log. So we get log of 7, the original argument, over log of the original base 5. And log of 3, log base 3 of 10 written using natural log of 10 over natural log of 3. And that concludes properties of logarithms. Thanks so much for joining this session, and I'll see you next time.